An unexpected change is about to shake the electric vehicle market. Elon Musk announced that Tesla is completely eliminating the use of lithium in its new batteries starting in 2025. For those following the industry, this is huge news. Lithium has been the backbone of electric vehicle batteries for years, but it has also been one of the main production challenges. Price fluctuations, complex extraction processes, and environmental issues have always put this raw material under scrutiny. Now, Tesla promises a technological leap that could redefine the entire industry. The question is, what will replace lithium? The technical details are still a mystery, but Musk confirmed that the company has been testing this new technology for 18 months at the Nevada Gigafactory. This means that the prototypes are already in an advanced phase, and the results have been encouraging enough to justify such a large-scale announcement. Tesla CEO is known for his bold promises, but when something reaches this level of disclosure, you can bet there's a concrete plan behind it. This change isn't just about innovation. It's a strategic move to reduce costs, improve efficiency, and eliminate the bottlenecks that hinder large-scale production. Lithium, despite being an essential element in current batteries, has become a nightmare for manufacturers. Its cost fluctuates unpredictably, which directly impacts the final price of electric vehicles. Additionally, its extraction is labor-intensive and creates environmental impacts that are increasingly under international regulatory scrutiny. The market has been looking for alternatives, but no one expected Tesla to make such a radical move all at once. This shift could open a new era for EVs, making production more stable and less dependent on a single resource. Another critical point is battery range. Without lithium, many wonder if the new models will be able to maintain the same level of performance or if we'll see a drop in energy efficiency. However, Tesla has proven in the past that it doesn't announce such changes without ensuring that the new materials provide at least the same level of performance, if not better. The 4680 cell technology, for example, has already brought significant gains in energy density and durability. If Tesla is betting on this transition, it's a strong indication that the new chemistry might be even better. Charging time also comes into play. One of the biggest challenges for the mass adoption of electric vehicles has always been the long charging times. With the removal of lithium, there's an expectation that this new chemical composition will allow for even shorter charging times, reducing one of the main obstacles for those still hesitant to switch from gasoline cars to electric ones. If this change truly delivers improvements in this area, Tesla might be on the verge of eliminating one of the biggest barriers in the market. The tests conducted at the Gigafactory indicate that the new technology is already in an advanced stage. This means that Tesla has not only found a viable alternative to lithium, but has also managed to produce these batteries at a level that allows for commercial scale application. And this is no small feat. Many battery technology advancements get stuck in the research phase because they are too expensive or impractical to manufacture. The fact that Tesla is already integrating these new models into its production line suggests that this barrier has been overcome. Researchers have realized that traditional testing methods do not accurately reflect what happens in the daily lives of drivers. In laboratories, batteries are subjected to continuous charge and discharge cycles in fixed patterns, something that does not occur in real life. In everyday use, the driver accelerates, brakes, makes small stops, and often leaves the charge partially in use for extended periods. These factors, according to the study, result in degradation up to 38% slower than what laboratory calculations predicted. Another interesting point from the study is the influence of different driving patterns on battery degradation. Situations like heavy traffic, where there are frequent brakes and accelerations, were once thought to be harmful to the battery's lifespan. However, The tests showed that these factors can actually help prolong its durability. This happens because electric vehicles use regenerative braking systems that convert part of the braking kinetic energy into electrical charge, reducing the need for deep recharge cycles and, consequently, decreasing the stress on the battery. This new approach also debunks a common myth: the idea that rapid accelerations are extremely harmful to the battery. The study's data suggests that small variations in energy consumption over time are less harmful than a constant and uninterrupted discharge, like those seen in lab tests. In other words, using an electric vehicle under real-world conditions may actually be more beneficial for the battery than the traditional testing standard suggested. Moreover, this discovery could directly influence the used electric vehicle market. Many consumers still hesitate to buy a second-hand EV due to concerns about battery degradation. If Stanford study is widely accepted and incorporated into vehicle lifespan calculations, the perceived value of used models could drastically change. A Tesla or any other EV with 200,000 kilometers on the clock may be viewed with less skepticism, as the expected battery lifespan will be much greater than previously estimated. The longevity of an electric vehicle battery doesn't solely depend on its chemical composition or the way it is tested in labs. Several external factors can accelerate or slow down its wear, and understanding these elements can make a significant difference in the vehicle's overall lifespan. How the vehicle is driven, the frequency of fast charging, and even the climate of the region where it operates are variables that directly affect battery performance and durability. While the Stanford study revealed that batteries last longer in the real world than in laboratory tests, it doesn't mean they're immune to degradation. One of the main culprits in this process is the excessive use of fast chargers. While they are incredibly convenient for those needing a quick boost, high-powered chargers subject the battery to high temperatures, which accelerates wear. The more often this type of charging is used, the greater the capacity loss over time. This is especially problematic for drivers who travel many kilometers daily and rely on fast chargers to keep their vehicles operational. On the other hand, charging the vehicle on level 2 chargers, those that take several hours to complete a charge, is one of the most efficient ways to preserve battery health. This type of charging is slower and more controlled, reducing thermal and chemical stress inside the cells. Additionally, experts recommend keeping the charge level between 20% and 80% whenever possible, avoiding both deep discharges and frequent full charges, as these extremes tend to accelerate battery degradation. In addition to external factors, the driver's own driving style can influence battery durability. Rapid accelerations, aggressive braking, and constant sporty driving demand more energy and quickly heat up the battery cells. However, the latest data suggests that natural variations in usage, such as regenerative braking and fluctuating energy demands, may be less harmful than the artificial cycles imposed in lab tests. This means driving an EV moderately, without constantly demanding peak power, can help prolong its lifespan without compromising performance. Another aspect that has gained attention is the influence of battery management systems. Tesla, for example, uses software updates to adjust charging parameters and temperature, seeking to balance range and longevity. The intelligence of these systems allows the vehicle to adapt its energy consumption and charging cycle according to the driver's usage patterns, reducing the negative impact of less than ideal habits. This means that with evolving technologies, batteries can last longer without the driver needing to drastically change their behavior. Moreover, the quality of the materials used in battery manufacturing has been advancing rapidly. New chemical compositions are being developed to minimize degradation over time. Tesla's 4680 cells, for example, were designed to offer greater durability and thermal efficiency, reducing the negative effects of heavy use. If the new lithium-free technology announced by Musk follows this same path, we can expect even more resilient batteries against adverse conditions and natural wear. The increasing durability of batteries is changing how people perceive electric vehicles. One of the main arguments against the widespread adoption of these cars has always been concerns about battery lifespan and the high costs of replacing them. Now, with studies showing that batteries last much longer than previously imagined, this barrier is quickly falling. If before, a buyer hesitated to invest in an electric car due to fear of needing to replace the battery after a few years, they can now see the vehicle as a long-term investment, just as reliable as, or even more so than, a gasoline-powered car. This shift in perception has direct implications for EV acceptance by the general public. For commercial fleets, for example, this new reality could be a game changer. Companies that rely on vehicles for deliveries, passenger transport, or logistic services always assess the total cost of ownership before replacing their fleet. If an electric car can travel hundreds of thousands of kilometers without needing a battery replacement, the investment becomes far more attractive. After all, not only are they cheaper to maintain than gasoline vehicles, but they're now also more durable than the numbers previously indicated. Another factor that could accelerate this transition is the reduction in lithium dependence, as announced by Tesla. With a new chemical composition for batteries, the expectation is that production costs will decrease and the supply of raw materials will become more stable. This could lead to a drop in the final price of electric vehicles, making them accessible to a larger portion of the population. If this prediction comes true, we will see an even faster growth in the number of people migrating from gasoline cars to electric ones. Tesla is already known for its ability to implement improvements through software updates, and this new phase of batteries could elevate this concept even further. If the company can optimize charging and discharging cycles based on the latest discoveries about degradation, vehicles could maximize battery longevity without the driver needing to worry about manual adjustments. This would make the Tesla experience even more intuitive and efficient, removing technical concerns from the end user. In addition to Tesla, other automakers are expected to accelerate their own battery projects to avoid falling behind. The EV market is already in a technological race, and any innovation that offers greater range, less degradation, and reduced costs can get company a significant advantage over its competitors. The change announced by Tesla could force the industry to rethink its strategies and seek alternatives to lithium, speeding up the development of new technologies and further expanding the electric vehicle market. The impacts of this change are not limited to automakers and consumers. The charging infrastructure could also benefit from more durable and efficient batteries. If electric vehicles can travel more miles without losing battery capacity over time, this means less frequent charging will be needed, reducing pressure on the electric grid. Additionally, with more efficient thermal management, the new batteries could minimize the risks of overheating and improve the performance of ultra-fast chargers, making the charging experience faster and safer for drivers. The Model Q, speculated as an affordable electric car, could be the key for Tesla to dominate the mass market. The major barrier for many consumers is still the high price of EVs, and Elon Musk has repeatedly stated that he wants to offer an electric car in the $25,000 range. For this to happen, reducing battery costs is essential. With the new chemical composition eliminating lithium and the uncertainties surrounding its supply, Tesla may finally achieve this goal, making electric vehicles accessible to a much larger segment of the market. If this forecast proves true, the Model Q could become one of the company's best-selling cars, completely revolutionizing EV adoption worldwide. In addition to the Model Q, the Model 3 will receive a significant update. Although it is one of Tesla's most popular vehicles, It has been on the market for a few years and needs improvements to remain competitive. The new model is expected to bring an updated design, enhanced aerodynamic efficiency, and, of course, the new batteries. This means that future buyers can expect even greater range, reduced charging times, and extended lifespan, making the Model 3 an even more attractive option. But it's in the next-gen Roadster that Tesla can truly showcase the full potential of the new battery technology. Since its announcement, this model has been promoted as a true electric supercar, capable of offering extreme performance without compromising range. If Tesla has developed a lighter and more efficient battery, it could transform the Roadster into a track monster, combining insane speed with range never before seen in vehicles of this segment. With a promise of 0 to 100 kilometers per hour in less than 2 seconds, it could redefine the concept of sportiness in electric cars. Another important detail of this new generation of vehicles is the possibility of greater integration with artificial intelligence and remote updates. Tesla already uses over-the-air updates to improve its cars over time. And with new batteries and greater computational power, the 2025 models could become even smarter. This opens the door for more sophisticated battery energy management, adapting consumption according to the driver's driving pattern and ensuring that degradation happens at the slowest possible rate. With so many advancements, an inevitable question arises. Will these lithium-free batteries be able to offer a range exceeding 500,000 kilometers before losing a significant amount of capacity? If this proves true, Tesla could be even closer to its grand goal, creating an electric vehicle capable of traveling 1 million kilometers without needing a battery replacement. This would be a gigantic leap for the market and would eliminate one of the last obstacles that still make some drivers hesitate to switch to electric vehicles. As Tesla prepares to take a big step with its new batteries and models in 2025, another revolution is happening behind the scenes: battery recycling. While innovations in battery technology are crucial for the future of electric vehicles, the fate of batteries that reach the end of their lifespan also needs to be considered. This is where LITHIUM, a UK-based company, comes in. They have developed a revolutionary recycling technology capable of recovering 97% of lithium and 99% of graphite from used batteries. This breakthrough has the potential to transform the electric vehicle market and accelerate the transition to a more sustainable future. Battery recycling has always been a challenge. When electric vehicles started becoming popular, one of the major concerns was the environmental impact of used batteries, which, after reaching the end of their useful life, would need to be discarded efficiently and safely. Traditionally, battery recycling has been a difficult task, especially for those composed of nickel, manganese, and cobalt, NMC, which require complex and expensive processes to extract valuable materials. However, with the growth of the lithium iron phosphate, LFP, battery market, recycling has become more viable and efficient. LITHIUM's major differentiator is its eco-cathode technology, which can recover large quantities of lithium and graphite, the two most critical components for manufacturing new batteries. This not only makes the recycling process more economical, but also helps solve one of the industry's biggest problems: dependence on virgin raw materials. If more companies like LITHIUM can master this process, the electric vehicle industry could significantly reduce the extraction of new materials, making production more sustainable and less impactful on the environment. Additionally, this recycling technology opens the door to a circular economy within the battery industry. Instead of relying on new resources for each new battery produced, automakers could reuse recycled materials to manufacture battery cells, which, in addition to being more environmentally friendly, would lower production costs. This change could have a significant impact on the final price of electric vehicles. making them even more affordable for the average consumer. At the same time, it would reduce the amount of electronic waste generated by the disposal of used batteries. For Tesla, this breakthrough in recycling is excellent news. The company is already incorporating LFP batteries into its models, particularly in entry-level versions like the Model 3 and Model Y. As the EV market grows, the number of batteries reaching the end of their useful life will also increase. Therefore, partnerships with companies like LITHIUM and the adoption of efficient recycling technologies could be key to ensuring that used batteries are processed effectively and reused in the production of new cells. This aligns perfectly with Musk's vision of creating a more sustainable future with affordable electric cars and no negative environmental impact. Moreover, LITHIUM's investment in new recycling facilities, such as its Plymouth plant, which has the capacity to process 300 kilograms of black mass per day, reflects the urgency and scale of this challenge. With a rapidly expanding global electric vehicle market, the demand for recycled batteries is expected to increase significantly in the coming years. The ability of companies like LITHIUM to process and reuse these materials will be crucial to meeting this demand, especially if Tesla and other leading automakers begin to expand production in global markets.